A fascinating novelty lighting choice that simulates the flickering appearance of a flame is the Balafire light bulb. This unusual light bulb, which was created by Robert Kipp in the 1960s, is a favorite for bringing ambience to a variety of situations because of its captivating glow produced by an oscillating carbon filament. A popular fixture in homes and businesses, the Balafire bulb appeals to people who value its nostalgic and artistic features thanks to its unique design and blend of retro charm. Number 7. Unusual flickering behavior. The flickering behavior of the light bulb in the video is intriguing and unexpected at the same time. This bulb flickers in a random and unpredictable manner, in contrast to typical flicker flame bulbs, which are designed to create a gentle, constant glow akin to candlelight. The artist uses slow-motion video and high-definition close-ups to document this occurrence, enabling viewers to see the sharp variations in light intensity and brightness. The captivating effect of this unpredictable flickering can captivate viewers and make them wonder what causes these anomalies. In order to lay the groundwork for a more thorough investigation into the fundamental physics of light bulbs, the author highlights that this behavior is out of the ordinary. The film stimulates viewers' curiosity and asks them to think about the intricacies of electrical occurrences in common things by presenting the flickering as a riddle that has to be solved. Number 6. Faulty design or construction. The author speculates that the bulb's odd flickering might be caused by a manufacturing defect or a design flaw as the story progresses. Viewers are prompted to consider the wider ramifications of quality control in consumer goods by this claim. According to the author, even small discrepancies, including changes in the gas pressure inside the light bulb, misaligned electrodes, or flaws in the materials, can cause noticeable performance variances. For example, flickering light may be the consequence of unstable electrical discharges caused by poorly positioned electrodes, or by the neon gas inside the bulb not being kept at the ideal pressure. This point encourages viewers to recognize the intricacy involved in creating seemingly simple items like light bulbs by highlighting the significance of precise engineering and thorough testing in manufacturing processes. By drawing attention to these possible defects, the movie also increases customer awareness of the need for caution when choosing products that are supposed to function dependably. Number 5. Electrical discharge mechanics. The investigation of electrical discharge mechanics in low-pressure neon gas is one of the main topics of the film. According to the inventor, in order for an electrical discharge to be successful, the gas's electrons must acquire enough energy to ionize it, which turns neutral gas atoms into charged ions with electrical conductivity. Under normal circumstances, this process makes it possible for electricity to flow steadily through the gas, producing steady illumination. However, this particular bulb operates under low pressure, which complicates ionization. Because there are fewer gas molecules available for ionization due to the decreased pressure, it is more difficult for electrons to hit with them and create a stable discharge route. The author artistically represents these ideas using diagrams and animations, simplifying difficult scientific ideas into manageable chunks. Viewers' comprehension of how gases react in various scenarios is improved by this comprehensive explanation, which also highlights the complex connection between electrical characteristics and the physical states of matter. Number 4. Current and voltage analysis. The inventor measures voltage and current in detail when the bulb is in use in order to learn more about how electrical factors affect bulb performance. This specific bulb uses an incredibly low current, less than 0.01 amps, according to the research, which results in a total power of only 2.5 watts. The energy available for prolonged ionization across the electrodes, which is required to provide steady light output, is limited by this low power consumption, which makes it crucial. Localized ionization occurs when current is not enough to sustain a steady discharge across all electrode surfaces, the inventor notes, and this phenomena directly contributes to the flickering behavior that is seen. Viewers learn a great deal about how electrical properties directly affect commonplace equipment like light bulbs by hearing a detailed discussion of these measures, including their relationship to Ohm's law and the concepts of electrical resistance. In addition to providing viewers with information, this analysis challenges them to consider the efficiency and energy use of household equipment. Number 3. Ionization behavior. In-depth discussion of ionization behavior in the bulb is provided in the film, with particular attention paid to how electrical discharges start at particular locations on the electrodes rather than evenly over their surfaces. The inventor notes that because of changes in the electric fields around them, discharge usually happens at electrode tips that are facing apart. Because it contradicts conventional predictions, this phenomena is very fascinating. One might think that discharges would disperse uniformly throughout all of an electrode's possible surfaces because of homogeneous electric fields. As an alternative, localized ionization takes place in areas that are most suited for electron mobility and gas ionization, usually at locations with the greatest electric fields or where electrodes have sharp edges that intensify the field. Through step-by-step instructions accompanied by visual aids, including animations showing electric field lines and discharge routes, the designer walks viewers through this intricate process. The basic concepts of electricity and gas behavior that underpin many electrical devices are highlighted by this investigation, which also explains why some light bulbs flicker while others continue to glow steadily. Number 2. Demonstration of Paschen's law. A captivating section of the film shows slow-motion video of dynamic electrical discharges as several parameters, including temperature and voltage levels, are changed while the light bulb is being experimented with. The author skillfully demonstrates Paschen's law, which explains how gas ionization happens depending on pressure and electrode distance using these visual aids. There is a particular link between these variables. According to Paschen's law, ionization gets more difficult as pressure drops or distance increases past specific limits, because there are inadequate collision rates between electrons and gas molecules. By altering these parameters in the course of the tests and documenting their impact on discharge behavior in real time, viewers may observe directly how modifications affect lighting consistency and stability. For audiences who are not familiar with sophisticated physics topics, this hands-on demonstration acts as an instructional aid by making abstract scientific ideas concrete and relevant. The developer helps viewers gain a better grasp of how environmental influences impact electrical phenomena by graphically depicting these interactions through captivating footage and concise explanations. Number 1. Growing popularity. Because of its distinctive fusion of scientific research and captivating imagery, the video has seen incredible success on websites like YouTube, swiftly gaining popularity and trending in several nations. Viewers are lured in by their curiosity about odd occurrences, as well as their desire to learn more about science through approachable narrative, which is why it is so appealing in addition to its educational value. By dividing difficult subjects into manageable chunks and keeping a positive attitude throughout the investigation of electrical phenomena related to light bulbs, the creator's captivating presenting approach increases audience involvement. Curiosity-driven learning about science and technology through easily accessible web content creates a sense of community as viewers share their opinions and experiences regarding comparable occurrences they observe in daily life, such as flickering lights or oddball devices. This rising popularity highlights the public's growing desire to learn more about the technology in their lives and shows interest in light bulbs, as well as a larger fascination with comprehending how commonplace products function through scientific principles. Due to its popularity among viewers who are interested in science and technology, the video is now trending in a number of nations. Thanks for watching our video and don't forget to subscribe.